So welcome everyone, this is lesson number 7, key expansion. Lesson number 7 of the AES tutorial, advanced encryption standard. So by the name key expansion, it means expanding the key. Remember when we were discussing, giving the summary in the beginning of this course, we talked about rounds, that we are going to go through a round of 10, that is 10 rounds. So each round is going to have a unique key. So this key is going to be used to scramble the text, that is the data, the more. So every round we have a unique key that is used to scramble or encrypt the data, and this key comes from our main cipher key. So we are going to replicate this cipher key 10 times, but not exactly. So I'm going to show you how we replicate this round key into 10, because we are having 10 rounds. Depending on how many rounds you are having is going to determine how many different keys you are going to be using. So 10 rounds means 10 different keys. So go over to projectfpga.com/AES, select key expansion. You will see the Verilog code for this. It's short as usual. So this is what the logic sim circuit looks like. It looks a bit clumsy up, but it's easy. I will explain. So let's first of all go to the input and let's see what's happening there. So for this is too big, I may probably not be simulating. So what it does is that it takes the cipher key, which is our unique password, then passes it through this round key generator. So remember the round key generator we talked about in our last tutorial. This is it. So but the major reason is passing it through. So as I was saying, the major essence for using this round key generator, we're actually the round key generator, the major sense for using it in the key expansion is because of this outcome word. This is the round constant. So this is what is going to generate, this is what is going to replicate the round key into 10 different places, giving us different round keys. So here the different round keys generated, we call it W. So you can see they range from 1 to 40 actually, right? Yes, they range from 1 to 40. And remember, four of these sets make up the 128 we are talking about. So this is one of the generated key expansion. This is 2 of it. So when you replicate it into 40 different places, that's when you find out that it's going to be 40 divided by 4, that is 10. So this is actually the 10 different round keys that we are generated. This is them, the 10 different round keys that were generated. I've labeled them W1 to W40 since 4 makes 1. So 40 divided by 4 is equal to 10. That is 10 different round keys. So how were they generated? Our main cipher key was being fed into this round key generator. And now watch closely and see what happened to this outcome word. Different constants, different values. Different constants, different values. Watch the outcome word and see what it did. These are different constants was fed, and you know that when you use different constant, different outcome words in this round key generator, if you use different round keys, watch here, if you use different round keys here, it's going to affect this ZOR, because that is where the round key came and entered this ZOR. Therefore it's going to generate a different output. And remember, this is not just one, it goes down to all of them because they are all the same. They are all the same 128 bits. So it actually affects every single one of them. So let's go back to this key expansion. So that is why they actually fed different constants to generate different outputs, and you are going to do them into 10 different places, which is basically what I've done here. We have 10 round key gen, this is 5, and this is the other 5. And another thing about this key expansion is that the inputs to each of these round key generators are not actually the cipher keys. The cipher key actually went as inputs to only the first round key gen. So subsequent ones like these ones and these ones and these ones had the inputs from the first one. So the input from this one went as inputs here and using a different constant altogether. So that means it's going to generate another different output entirely. So here this one is fed back into here and using another different constant altogether, generating a different output altogether. Now the output is likewise fed into here again, then using a different constant altogether, giving another different entirely output. This is repeated 10 different times. So this is how we're able to generate different round keys, and that is how we sum them up. You find out that at the end we now brought all of them down here. So each of them, like this one was brought down, this one was, in as much as they were still fed back as inputs to the next state, they were all brought down together to make up this W, which we came down. See, this is where all of them were brought down. Total of 10 different rounds. So these are the different rounds generated, different round keys when we use the key expansion. So this is basically what the key expansion does: generates different round keys for each of the rounds. So please go through the tutorial on the website. You see the code there, read it, it's very easy to understand. So this is where we sum all of them up, the newly generated outputs, we call them W. And then also, so that's it. See, this is where the round key generator was added as a subcircuit, which we use here. Then this is the first one, the rest were generated 9 times. So this is the round key constants. These constants were fed in for each round to generate different outputs. So please go through this very code and my tutorial. Hopefully you understand everything.